Okay, in this topic number 2, we're going to be talking about trigonometry. It's basically an extension of what you've learned in JC1, which is the paper 1. We're still going to be talking about solving equations, proving identities, right? Things like that. The only difference is that, there are just few identities, few things that, that's being added up, right? Like, for example, reciprocals. Yeah, secant theta is equal to 1 over cos theta, cosecant theta equals to 1 over sine theta, and cotangent theta, which is equals to 1 over tan theta. So reciprocals introduced here. And then Pythagorean identities is not only a matter of sine squared theta plus cos squared theta equals to 1. There are two more variations there. Yeah, tan squared theta plus 1 equals to secant squared theta. And then the other one is 1 plus cotangent squared theta equals to cosecant squared theta. And then also going to be talking about angle sum. Sine A plus minus B equals to sine A cos B plus minus cos A sine B. Cos A plus minus B is equals to cos A cos B minus plus. So be careful with this. Yeah, this one is plus minus. This one is minus plus. Sine A sine B. Tangent A plus minus B is equals to tangent A plus minus tan B over 1 minus plus. Also be careful here. Tangent A tan B. Sine 2a is equals to 2 sine a cos a. Cos 2a, we have three variations here. Cos squared a minus sine squared a, 2 cos squared a minus 1, and, I forgot, 1 minus 2 sine squared a there. And last but not least, we have tangent 2a equals to 2 tan a over 1 minus tan squared a. Right now, what we're going to be doing is to try and prove an identity using some of these identities already given to you. Proof secant theta plus 1 over sine theta plus tan theta is equivalent to cosecant theta. Now, the first thing that you need to do is you have to start with either one of the sides. You cannot start together. You have to choose where you want to start. You want to start left-hand side or you want to start right-hand side. The rule of thumb here is that try to start with the one that's more complex. Like, for example, in this case, the one that's more complex, I would say left-hand side. You can derive a little bit more, right? Now, if I want to start with left-hand side, then I'm just going to rewrite this real quick. Secant theta plus 1 over sine theta plus tan theta, right? So, okay, looking at this, I have two things here. First, I have secant theta, which is a reciprocal. I have sine theta and tan theta, which is like a normal trigonometric ratio. So what am I going to do here? I'm probably going to be dealing with this in terms of sine and cos. Yeah, because secant can be rewritten in terms of cosine, and tangent can be rewritten as sine over cos, right? So let's try that. Secant theta is going to be equal to 1 over cos theta plus 1 over sine theta plus sine theta over cos theta. Okay? Now, the next thing that I observe here is that, hey, the right-hand side, the one I'm going to find or I'm going to show, there's no fraction here. So as much as I can, I want to reduce the fraction. How am I going to reduce the fraction? The fact that I have fractions inside a fraction right now, right? I mean, my numerator has a fraction, my denominator has a fraction. How am I going to be able to reduce that? So it's going to be in a non-fraction kind of form. So the best bet to do this is, why don't we try to multiply this with cos theta? The numerator, I mean, yeah? Try to multiply this by cos theta. What do you get here? I will get 1 plus cos theta. And how about if I also multiply this by cos theta? What do I get? I'll get a sine theta cos theta plus sine theta. And the reason why I would like to multiply this numerator and denominator with cos theta and cos theta, because cos theta over cos theta is equals to 1, right? So it's the matter of how you manipulate the expression basically to get like a simpler form. Now you get here, you got 1 plus cos theta, we got over sine theta cos theta plus sine theta. I mean, this is pretty much obvious if you could see that sine theta can be factored out, right? So I get something like this, and then it's very much obvious right now that I can erase this. I can they cancel out, getting me a sine theta. And therefore, 1 over sine theta is equals to cosecant theta, and that's going to be my right hand side. Okay, so remember again, choose a side, start with the complex ones, and then all the way getting to a simpler one. Okay, another example here. Yeah, we're about to prove cos x times cosecant x plus tangent x is equivalent to cotangent x plus sine x. Now, again, the best way to do this is to choose the sides that's more complex. In this case, I would say this side is more complex, so we'll start with the left-hand side. Rewrite this again, cosecant x, cos x times cosecant x plus tan x. So what happens here? Now we got cos x here, we got cosecant x and tan x. Again, same as the previous example, we can probably rearrange cosecant x and tangent x as a sine cos kind of thing, right? So cos x, cosecant x is going to be 1 over sine x plus tangent is sine x over cos x. Now let's look at this. Very easy. Cos x over sine x plus sine x. That's super easy, right? Now we got one part of the one that we were trying to prove. It's just the other part, cos x over sine x. But hey, so as the reciprocal, cotangent is equals to 1 over tangent theta or cos theta over sine theta. So therefore, this is going to be equals to cotangent x plus sine x, and that's going to be your right hand side. And you've proved. Okay, the third example when it comes to proving identity is to prove cos to the 4th theta minus sine to the 4th theta over sine squared theta is equivalent to cotangent squared theta minus 1. Just like what I told you last time, you start with the one that's more complex. Yeah? Which one's more complex? Left-hand side or right-hand side? I would say it's left-hand side, right? This comes in fraction, where this does not come in fraction. So we'll just start from there. Cos to the 4th theta minus sine to the 4th theta over sine squared theta. Now this is a challenge. Yeah? How do you tackle this? First is maybe, is there anything cos to the 4th theta in any of these identities? No. Sine squared theta, yes. There's maybe this. There's many other things that we could probably look into. Say for example, this one's also involving sine squared theta. Let me just rewrite this real quick, yeah, so that you will get the better picture of what I'm talking about. This is basically an a squared minus b squared, right? A difference of sum. So if you could see here, this is going to be equals to cos squared theta plus sine squared theta times cos squared theta minus sine squared theta over sine squared theta, right? Now, from here, you know for the fact that cos squared theta plus sine squared theta is equals to 1. So we're just going to erase all of those expression, leaving you with cos squared theta minus sine squared theta over sine squared theta. Now, please look at this real quick. It's cotangent squared theta minus 1. Right now, it's in terms of fraction. And the other one is minus 1. Obvious to see that, hey, this is going to be like this. And that's going to be cotangent squared theta minus 1. And that's going to be your right-hand side. And you proved the identity. This is also important, yeah? The fact that a squared minus b squared equals to a plus b times a minus b. In this case, we use a to the 4th minus b to the 4th, because a to the 4th minus b to the 4th is a squared squared minus b squared squared, right? And that's equals to, well, a squared plus b squared times a squared minus b squared, yeah? So you might want to look into that also.